All, I'm Niroshan. Today I'm going to demonstrate about my applied project, which is a DSL for visualizing climate data. In my previous video, I already explained about my project, what is a problem statement, what is a DSL, DSL background, the current world DSL examples, pros and cons, data visualization techniques, and why it is important, the raw data, how it looks like, and I already talked about the main use case diagram, sequence diagram. I will explain a little bit about sequence diagram. So as a user, you're going to create a source file by using DSL syntaxes. So once you create a source file, you will run the source file against the DSL compiler. So DSL compiler is smart enough to identify all the syntax issues, all the corner cases, all the negative scenarios, and load all the modules and all. So if there is any validation issues, it will throw domain specific error message to the user, so user can understand those and correct those errors and rerun it against the DSL compiler. So if everything is good, so it will load the module, load the libraries, and it will call the module and also pass all the relevant data to the module. So module will retrieve data from input folder and then do validations and also do pre-processing algorithms and calculations and all. So if there is any validation issues, it will again throw meaningful error message to the user, and user needs to do the same process again and again until unless if to get the correct output. So if everything is good, it will give the correct output, or it will generate another output file. Here's a class diagram, a DSL design. In this DSL, we centralize entire process. And here is a process DSL architecture, and from here onwards I'm going to use my project. So in my project I use Ubuntu uh, operating system, and for my convenience I use command line and remotely connect to the Ubuntu operating system by using port 889, and also use Jupyter notebook for the demonstration purpose. The Jupyter notebook is running already in this terminal. I also use another terminal to run each module. So here is the main folder structure in my Jupyter notebook. So I have few directories which are input, libraries, module, output, source, and this is the main program. So input obviously contains all the input files. Output, if any module is generating any output file, it will goes here, and all the libraries goes here. Currently I have one library called colors to differentiate print outputs, and here's the inputs folder, and likewise, and I'll come to the module and source folder. So let's open the main program. Here's the main program. What it does is smart enough to identify all the syntax issues and all the validations, all the negative scenarios, corner cases, everything will handle by this guy. So if the input file is in different directory, if the input file is in a real-time data, then it will take from the URL which is provided, or otherwise by default it will take it from the input folder, and it checks whether the input folder is exists, whether the whatever the path is exists or not, and it's smart enough to identify all the things. And if the debug is enabled, then it will give meaningful informatic messages for the user. And if everything is good, then it will load the modules and pass it will call the module and pass all the relevant syntaxes and variables and parameters. So I'm going to run I have several modules in this version. Create diagnostic, georeference plot, quick plot, sea surface temperature, sounding plot, surface temperature, total pressure, wind speed, and wind speed 3D. So I'm trying to run all these modules. Let's move to the quick plot. So here's a quick plot uh, uh, Python program. So as you see, it has a lot of coding. Even it's a simple program, but still it has a lot of coding. So that's why you need to use this DSL for the climate data visualization. So in this DSL, what you need to do is you just need to, let me open another window for the source files. You just need to create a simple source file which is in JSON format, and you have all the syntaxes, all the things that you can pass it. You don't need to write this many code, you just need to write the source file, and that's it. In this quick plot, you are providing a variable which is specific to the your input file. So normally the domain expert knows what kind of variables it contains. So let me quickly run it for you. There you go. So here's a quick plot. So based on the variable t2, it provides, since I have the debug enabled, so it provides all the meaningful all the relevant information. So here's a path variable, and it provides the variable information, what kind of description it has, unit, it is Kelvin, dimensions, variable types, shapes, and all the relevant information specific to that variable. So it's a simple program, but it has a lot of coding still. So then let's move to the other total temperature. So total temperature, let me quickly move to the total temperature. Here's the total temperature. It has a lot of algorithms, coding and all. So but in this DSL, you just need to create this source file. So let me quickly run that one. There you go. Here's the total pressure diagram based on the parameters given based on the file. So likewise, let me quickly run the sounding plot too. This is a source file for the sounding plot. You can provide additional parameters for that. And the sounding plot Python program is a huge program. It has a lot of calculation, again different algorithms, and run that. The sounding plot diagram, and based on the longitude and latitude for that specific location and all the min max variables, it will generate this output file. So see how simple it is. You just need to write this source file, and that's it. And likewise, let me run the wind speed. So in this wind speed, I'm going to use this one, not this one. Wind speed diagnosis, two modules I'm going to cover in the same. So in this module, what I'm going to do, I'm going to generate the wind speed diagram, and also by using that module, I'm going to enable create diagnostic true. So that means after all the calculation is done, it will create a new file with this name, and if it does not have the name, it will use this file and use the variable which is provided. This is mandatory. So based on those information and all, it will create a new variable called w2, and it will store in this file location. So next time you can use that file directly instead of running this module again and again. So let me quickly run that. This is the wind speed diagnostic source file. So it will generate this file, and it's generated the output file as well in this location, and it has all the data types and all, and we can see the output file over here. Let me quickly go to the output folder. Here's the thing. So now since I generated this, now I can use a quick plot module to see the same output. So I already generated that. I already have the source file for that. Here's the source file for that. I'm using the generated output and WRF file, and passing the new variable. Let me quickly run that one as well. This is quick plot. Yeah, W10. Okay, there you go, and I'm getting the same output with all the data. See that the things that we pass, it is a unit, mph, description, and all the information it is there. So that covers two modules, and let me open wind speed 3D. This is one of the main module, low level wind shear. This is one of the main thing that we really need, the aircrafts or for cargo ships. This will calculate whether wind shear is there any sudden changes in the wind speed and all. So this is one of the main program that can be used to determine whether the aircraft can go through several sections. I will run this module quickly, and this module has a specific another feature as well that I implemented. So you can give this threshold value. Based on that, it will generate another output file to see the areas that we need to avoid while traveling through aircraft or while going through the cargo ship. Let me run this one. This is wind speed 3D, and it takes some time. Let me quickly. Okay, and also if you're really interested about how it is works, how the flight works, so I already provide some information, YouTube links that you can go through and I understand what exactly the LLWS is. Here's a diagram, so you can see lower level wind shear in knots unit, and these are the areas. So if the red areas we need to avoid. Likewise, let's see, if I close this, it will generate the another diagram based on the threshold. So these area, the red areas, we need to avoid because those areas has some low level wind shear. So, and this is it, and I have more modules. I will go quickly another module. Let's say sea surface temperature, and here's a sea surface temperature. In this module I'm using real-time data, sea surface temperature. So I'm using, this is a source file, I'm using a URL. It's a real-time data for December 4th, yesterday data. Let me run this one as well, and this is a path, and this is the data, the data that I am retrieving from this URL, and you can see the output in a minute. So it takes time. So this diagram contains all the sea surface temperature based on yesterday. So these areas has more temperature and the blue areas has low temperature likewise. So with that said, I have a few other modules to show you, but I don't have enough time to show you. So if you have any questions, please feel free to comment below, and thank you.